All right, fellas, we're up to lesson 9 here. We're looking at the thin lens equation. We did the ray diagrams for lenses. Now we're going to look at the equation. Okay, last lesson for this chapter. And then we're going to move on to a project for next week or two. All right, so basically there's a few things you need to know. If it's converging or diverging, converging, remember, is like this, where it focuses the light together. We're going to say F is always positive. All right, no matter what, we just say, hey, the focal point is positive. Light's coming together, it's positive. Even though it's on the right side, it's a little different than mirrors. Remember, mirrors is a little different, but for lenses, converging always positive, diverging, because that takes light that comes in parallel and bends it away from this focal point. The focal point's back here, where we trace them backwards. We're going to say F is always negative. So when you set these up, just make sure you do that, and then it actually is very similar to lenses again. The thin lens equation. The reason it says thin lens is because this actually wouldn't work out so nice if it was a very thick lens like this type of thing. We're talking about lenses that are pretty thin relative to how tall they are, and this equation works out pretty much accurately as long as it's a relatively thin lens. But guess what? Same equation as mirrors. 1 over di plus 1 over do equals 1 over f. Okay? So I'm just going to go through these same examples that we did last week, and then it'll be the same on your homework. It'll be the same problems, just you got to use the equation just to double check your answers. All right? So if you look back at that first one, we got 3 examples. It was converging, and they said DO was 6 and F was 4. Okay, this is converging, so I'm going to say positive 4. Find your DI, find your magnification. Okay, and I'll tell you what, just like mirrors, so you probably can get away with not watching this video if you just want to know, hey, if it's diverging, I just got to make sure F is negative. That's the only really new thing here. So we'll just do 2 examples. I think we'll be fine. All right, so 1 over 6 plus 1 over 1 over di. I should set up 1 over di plus 1 over 6. That's how I set them up. Okay, equals 1 over 4. Okay, minus 1/4 minus 1/6. 3/12 minus 2/12 is 1/12, so di is 12. Remember, magnification is actually the same equation, negative di over do. Okay, exact same equations that we used for mirrors, actually. Negative 12 over 6, negative 2. Okay, double check that with that picture. Okay, I'm looking at di is 12 and magnification is negative 2. This was a picture from last week. Okay, yeah, it's way out there. I'd say 12. I don't know what I estimated. Negative 3.5. Oh, up here. 12, yeah, I got it right on. I said, man, I was right on that, negative 2. Okay, positive image distance actually means over here on the right. Just another little detail. Let's skip down to this diverging one here at the bottom. It was the 3rd example we did on last week, and I think we'll be good if we just do these 2 examples. Okay, so this is diverging. DO, they told you, was 6. F was 4. Again, what's DI? What's your magnification? Okay. Make sure you show your workout on these guys. You guys have been doing a great job so far of showing everything out. All right, so 1 over di plus 1 over 6. In this case, F has to be negative. That's the only key. All right, because it's diverging, that's why I put negative 4 there. So I got to do negative 1/4 minus 1/6. So negative 3/12 minus 2/12. We're talking negative 5/12. Okay, so di is actually negative 12 over 5. Or negative 2.4, right? And then magnification. I don't know. I guess I'll probably just do as a decimal here. Negative of negative 2.4 would be 2.4 over my DO was 6. 2.4 over 6. 24 over 6 is 4, right? So we're talking 0.4 is my magnification. Again, double check if that matches up with this picture here from last week. I'm looking at negative 2.4 for my image distance and 0.4. I said negative 2.5, which is pretty close. So on this left side is actually negative for your image. And I estimated 0.4. Man, I was right on those guys. You guys have a really good teacher. That's it, guys. Pretty straightforward. It's just like with mirrors. Be ready. Next thing, we're going to get into an activity or an engineering challenge for your next lesson. Get away from this content for a little bit.